Alright, what is going on, everyone? The Teen Engineer here. And today we're going to continue with the Skywalk Towers series, so let's get right into it. I'll be showing you some more towers and probably maybe some bug fixes or some backhand code or how I did things in my game. So let's go. Okay, the loading screen here. Let's just wait through that one. Cool. The candy tower is pretty much done, although I could show you guys some how I did some things on it. Um, but actually, yeah, let's go. You know what? Let's go to Candy Tower. I want to show you guys something. Okay, cool. These gummy bears. Ready. Gonna walk through these. Okay, cool. All right, I want to show you guys how I did um these things. These things that are moving or turning. Uh, for one reason actually, because let's go on it. Yeah. So as you can see uh on this like what this lollipop I'm on, I'm basically turning with it, and that might seem kind of easy to do, but you can realize that when you try doing it with code, it doesn't actually work. It only turns, but it doesn't take you with it. So you just stand there and it just turns without you. Um, so you can't achieve this with code. You can only achieve this with the constraints of Roblox. Um, So that's what I'll be showing you. It's called a cylindrical constraint because there are different types of constraints. There are hinge constraints, prismatic constraint, but a cylindrical constraint allows you to move an object while it's turning. So here we can see, guys, that it is turning and moving at the same time. So it's a cylindrical constraint that we need. And I'll just be showing you a bunch of constraints, and yeah, that's pretty much it. So I'm just gonna leave, and I'll be showing you how I do this. And there is some code associated to it, but it's not the code to move it. It's pretty much the code just to tell it where to stop. Uh, so yeah, I'm trying to leave Roblox. Yeah, cool. Okay, let's edit that. Go to Roblox Studio. Let it load up. Okay, cool. So loading place. Okay. Okay, I have to remove the UI actually for me. Show development GUI. Disable that. Cool. So let's see. So really, when you want to move an object, you have to ask yourself what do you want it to do, and because on this one I knew I wanted that the player moves with it while it turns, and so that's how I knew I had to use the cylindrical constraint, which we can see here, and yeah. So if you click on the plus, I'm going to show you guys constraint. There are a bunch of different types of constraints. See, this is like a ball socket constraint. It's like a if you want to move something, if you want to turn something, it's like a full rotation XYZ. Cylindrical constraint is only in one axis, but you can also move it. Hinge constraint is just rotation in one axis, kind of like a door. You know, doors have hinges. Know what that is. Prismatic constraint is you can move it. It's like a cylindrical constraint, but you can't rotate it at the same time. You can only move it. Um, most of these things you're not going to use except the like cylindrical constraint, hinge constraint, and prismatic constraint. If I'm being honest, weld constraints are just if you would like to weld an object to another one. Like if there's an object that's moving and there's another object you want it to move with it, you can use a weld constraint. But I'll go into more details a bit later. So let's see what's going on here in this model, which is the one I want, right? Yep. Okay, so if we take a look, we see that, okay, this is called test. I'm not sure why, but this lollipop thing is called test. So let's just rename that. And so let's have a look. There is the lollipop. There is target one, which is an invisible block, an invisible part. And there is target two, which is another invisible part underneath it, which is currently like engulfing right now. And What these two things are the boundaries of where it's gonna move to. Where it's gonna move to back and forth. So it's gonna move from this part to until it touches the other part. So this one. Cool. So let's see. In the target one, so where it's not touching currently, uh, this is the other part, invisible. We can see that there's an attachment. Okay, this attachment is just like this thing. It's not really an object. It's just an attachment that you need to have constraints because constraints are like constraints. Basically, they need attachments. Um, so the first attachment is to the part. So to the part that it's going to. You can see here it's in like I believe, yeah, it's in the it's towards the bottom. It's at the bottom face of the part. So you can see the attachment, and it's facing towards the bottom, towards this axis, which is the x-axis, right? So it's using attachment axis x because it's moving in the x-axis. So then let's take a look at the other attachment, which is the actual part that's moving itself. So the attachment is inside the lollipop because it's actually the part that's moving, and we can see it's another attachment. And how you can add these, if you're wondering, you just click on it, click on the part here, and click on the little plus icon, and you just you just type in attachment, and then let's see, where did I put it? I'm not even sure which one's the right one. I believe, yeah, okay, this one is the right one because it's in the right axis. But yeah, you can just turn it and rotate it according to your needs. So then let's take a look at what the cylindrical constraint does. Of course, we put it invisible unless you want to see that, but I don't really want to see that. Okay, cool. Okay, let's get to the interesting stuff. Now, the angular velocity is the speed at which it's turning, and it's 0.5 right now. If you put it higher, it's going to be faster, but I think 0.5 is honestly really good. So the motor max angular let's see what it was written. Motor mass angular acceleration. You want to put that as high as you can, honestly, because to avoid this is like some physics, but if you want to do something like me, just put it at the maximum you want, and you'll be fine, honestly. And the torque is the same thing. It's like if you if you hover over it, it's gonna tell you that like the torque is basically the force that the motor can apply, and you just want to put that as high as you can because you don't really want any problems with that. So just do those two highest as you want, and the angular velocity, then you just choose according to your needs. I think 0.5 is good for this one. The attachments, of course, is the two attachments that you already chose, and just remove that. Okay, so you just click on that and then click on the attachment that you need. And here, the angular actuator type, mine I use motor, and the motor I think is the best one because it's really smooth and everything. But I don't like to use the servo, I'm being honest. So for my case, I use the motor, and it just does what I needed to do. And here we can see the motor has its this is the motor, the angular actuator type is for the rotation, right? So this is this angular, so it's angle, so it's the rotation, and we want to use motor. So let's close those things, and let's have a look at the actual moving of the lollipop. So it's going up and down. I'm using a motor because we can see the slider here is a motor, and max acceleration, infinite again, as before, infinite. The max force, basically the highest number you can put in your keyboard, is 9999, and velocity. It's basically the speed, and mine is -3 because I wanted to go up at 3 at velocity of 3. I'm not sure what's the units on this. It's probably studs per second, maybe. But yeah. So you just put this, and this is the direction. But since the attachment was like reversed, and I just need to put it in a negative. But you'll see, guys, that you can adjust these as you wish, but I'd usually keep the motor max force and motor max acceleration at infinite, highest possible. And so you can just change these, the velocity and whatever else you need. So let's look at the script because that's the one that's going to tell you where to go and where to stop and whatever. So let's close this. Okay, cool. So we're referencing the lollipop, so part script.parents target, so the part that it stops at. So first one is here, the second one is inside it. So target one, target two, and okay. The set network owner is uh is basically every part that moves is basically has a network owner, which can be either the server, a client, or yeah, it's basically the server or the client. And says the player. Okay, and if you set the network owner as nil, then it sets it to the server. Now the difference is, let's see. I'm gonna show you guys the network owner to server Roblox. By default, yeah, server. Okay, um, let's have a look. I just want to make sure that nil means okay, cool. Set network owner to nil. Let's see. Okay, yeah, this is for the okay, cool. Let's see. Good way. Okay, cool. Set network owner. Yeah. Okay. That's okay. That's okay. Okay, cool. Okay, but basically, I'm pretty sure that if you set the network owner ownership to nil, then it sets it to the server. See? Yeah, see? So it says set network owner server. So the difference is that if you set a network, if you set a part network owner to the server, it's it's gonna run the same for everyone. And the network owner is basically the owner that like manages the movement of the object. And usually you want to set that to the server unless let's say you have like really you want to optimize your like your parts moving, but I don't need that, and I honestly it didn't lag for me. So yeah, but if you want to try this, you what you can do is you can check which part jumped on the lollipop. I mean, which player jumped on the lollipop, and you want to set the network owner to them, which would be okay. Which would be okay. But me, I think I found that when I did that, like when they jumped out of the lollipop and you set it back to the server, there's kind of like lag there. So I don't see any problem with setting it to the server as long as it's not laggy. So that's what I'm doing here. So I'm setting it to the server. I can put that setting network ownership to the server. Okay. So now where the part is moving, so the lollipop is moving, and we're checking if the lollipop touched something, and we pass in the part that it touched, and we check if the part's name is target one, which is the name I set it to. So this is so I'm basically checking if the part is target one, which is this one. So if it touched the top, if it's at the top of its trajectory, then we want to uh, change the velocity, change the direction of the velocity, not really the velocity. Like we don't want to change the speed, we want to change the direction of the speed, so it goes back down. If it's going 7 and we like 7, which is basically to the top, and we put it at -7, then it's gonna go back down, which is basically what we need. But I'd like to see something here. KSB -7, but it doesn't really change anything because I'm already setting it again, so it doesn't really change much. Okay, and once it goes back down, it's gonna hit this second part here, target 2. And I'm checking. If it hits target 2, then I want to change the velocity back to the opposite. So it goes back down, it goes back and forth, and it's gonna stay there forever. And if you don't do that, you see what happens. let's say we continue that like that, and we run it as the server. Uh, Run as a server. We don't really have a player. We don't need one. You can just see that it's just gonna go into oblivion and it's gonna hit a bunch of stuff. Let's see. Let's see what's gonna happen here. Okay, now it's just stuck. It hit a lollipop. Well, this is taking a lot of energy from my computer, so I don't need that. Back to -7, just a little demonstration of what would have happened. Okay, cool. So, what else did I want to show you guys? I wanted to show you something else as well. This one. Let's take. Oh wait, this one is the same thing. It's basically the same thing. You can see the second part here. Cool. I want to show you guys this one because this one is actually pretty different. Because I told you guys at the beginning that you really want to determine what kind of rotation or moving of a part you want. And in this one, I realized that I kind of don't need the player to move with it because the player is going to stay on this rod, and if they hit this part that's moving, they're just going to fall off. So I don't need the player to move with it. It's just the collisions are going to take care of it, you know. But with this one, the collisions won't take care of it because it's turning in this way. It's turning, so it won't really. The collisions won't take like any part of it. It's just that this thing is turning, and if I use the script for it, then the player wouldn't turn with it. But this one, I can just make it turn, and once the player gets stuck there, let's say in the middle, it's just gonna get pushed. So I told myself I would just simplify my life if I did a script with this. And you might be wondering, where's the script? I don't see any script in it. And that's because I used a local script for this. And the reason is that I've had a lot of trouble rotating parts and moving parts in this game. And the reason to that is because there was a lot of lag and I had to find different solutions. And the solution I found for this is to put it in a local script, which makes it 10 times easier. Basically, it doesn't lag anymore because the network owner is to the player, and it's basically moving like every person's computer is handling it to their own speed, which is literally perfect. So I put it in the starter player, which you can define a bunch of local scripts here, and you can see it's this one. I named it the same thing. So let's have a look at that. It's really, really short, as you can see. Cool. So first thing I did was I initialized a variable called run service, and this is basically getting the service called run service, which is going to help us to determine the frame rendering of the computer, and so it doesn't lag. Like instead, people would just do like wait, but this is like it doesn't really take into consideration that the user's frame rate would be different, and the run service does, so it's way laggy. If you just add this line, it's super easy. And here we're just initializing the model because we need the model to move it. So just go into workspace, wait for child, find the part, right? That's the part. Cool. And then we go into a while true loop, and you might be thinking, why isn't this crashing? I'm in a while true loop. Is because I put a wait here. If you put a wait, it'll be fine. So yeah. Okay, now the part.c frame. This is just changing the parts orientation. So the C frame, you can determine like the position, orientation, but this time I'm just determining the orientation. So I'm just taking the parts original C frame, I'm making it equal to the parts original C frame, so nothing changed, and then I'm adding a certain angle, and the angle I'm adding is 1 radian in the x axis because XYZ, so C frame that angle is 1. And you don't really need to know what's a radian. It just you can just experiment with this and put in values like 10, and then if it's too much, just 5. You don't really need to know what's a radian. But I want to show you guys. Yeah, we can see that it's in the X because like when you select it, we can see that the arrow in that's red, which is always the X, is the one that we're rotating about. So we can see that we're rotating around the X arrow. Like if you were rotating around the Y, then it would be like doing like this, which is definitely not what you want. You want around the X, which is perfect. Cool. So that's basically much. That's pretty much it. If you want to make this faster, you can make this 10, 100 if you're crazy, you know. Um, but yeah, that's pretty much it. So yeah, and I'm basically doing that for literally everything here. You can see here we're rotating. I'm using a script here. Here I'm using a cylindrical constraint. You can see the parts. Using a script here, script, cylindrical constraint, um, and that's pretty much it. So yeah, if you guys like this, like the video, subscribe. Of course, you can play this game. You can play this game. It's gonna be in the description. You can join my group as well. Let's try to get to 100 100 members. And yeah, that's pretty much it. Bye bye.